Hey, hi, hello. Hi. Well, nice to meet you. That was like a great introduction. But I'd love to keep things simple. Okay, so like I really want to like make a simple presentation, help everyone understand what we are going to be talking about. So I'll make one comment before I start, okay? And this is important. I'm not gonna be, so when you make like any presentation, you have to choose between being like accurate and being understandable, right? I'm gonna go for this. I'm gonna go for just being easy to understand rather than being accurate. But if you want to get like references, studies, scientific articles, like about the things that we will be talking about, I'll give you the bibliography at the end. Okay, so you will have the source, the references, and you will be able to check everything. That was the comment. Now, let's get started. And, well, you know about me a little bit, but I'd love to know about you in general. So let's play a little bit of a game together, okay? Let's raise our hands, and I'll ask you a question, okay? And we'll all raise our hands to answer the question. So what's the question? Well, I'd love to ask you, how familiar would you say that you are with this thing that is called a knowledge graph? So like, have you used it? Do you know more or less? Okay, well, okay, good. a little bit. Some hands, okay, good. And how familiar are you with LLMs, large language models? More hands, good, great. I love that. Great, okay, so then I have the last question, which is how technical should I try to be? So, okay, so there's a mixture because I see some hands that are like this and some hands that are like this. So I'll try to like explain things like so that everyone can understand, but I also have like some more technical slides that they're hidden in the presentation. But if you want like more technical things, we can have some questions at the end. So like you can ask me and like we can talk about more technical stuff, okay? Good? Great. So let's start. What are we gonna be talking about? Well, we will have 8 sections here, okay? So first of all, we're gonna be talking about what's a knowledge graph. What's this thing, right? Then I'll give you like some examples of like types of knowledge graphs that exist. Then we're going to very briefly talk about how we can apply artificial intelligence to knowledge graphs. Very interesting, but I won't really go really deep into this thing. Those 2 sections are going to be talking about that, but just from a very broad outlook. And then we'll be talking about what can we do with this in the real world? What are the applications that we can actually apply them for? And the interesting part is, there's some things that we are going to look at that are limitations, things that current AI can't do. So how can we solve that? Those are the last sections, okay? That's the structure of the presentation, more or less. That's what we are going to be talking about during the next minutes. And, well, let's get started, right? Because it's going to be super exciting, so I hope that you will be here with me during the presentation, and I'll try to make it, like, a little exciting for you as well. So what's a knowledge graph? Okay, very simple. A knowledge graph is just like a type of data structure, right? Like you can think it's sort of like a database. I put data here. So it's a type of data structure. It's made out of circles, right? Nodes that are connected with lines, links, and it's just that, right? It's just circles connected with lines, and you can make loads of different representations of the knowledge that we have in the real world just with circles and lines. So they're very flexible, very, well, very powerful data structures to represent information in many different ways. And we can apply machine learning to them, but we can also apply natural language processing to them. Or, and that's a little bit what we are going to be talking about today, we can combine them. So that's the idea. That's a knowledge graph, right? Got it. Good. So that's a knowledge graph, but what's the types of knowledge graphs? Well, types of knowledge graphs, 4 main things, okay? We have knowledge graphs that are about like Wikipedia. So Barack Obama is the president of the US, things like that. We can encode this knowledge into a knowledge graph form. But we can also have things that are about common sense. So when I wake up, I get out of bed, or things like that. You know, like that's another example. Then domain-specific knowledge graphs. That's, for example, something that we work with at my company. So like diseases that relate to certain genes, or very specific technical domains can be modeled as knowledge graphs as well. And then there's another area that is called multimodal knowledge graphs. But to be honest, this thing is like, I haven't seen those in real life. It's like just a theoretical thing, but I haven't really seen the fourth thing being actually applied. The most prevalent part of research has been done on common sense knowledge graphs, so the second thing here. So that's what researchers tend to focus on when they develop new techniques. But the three things, like the three first things, I'd say they are very interesting in general. So those are some examples, some types of knowledge graphs that we can have. I'm going to explain something I'm going to do during the rest of the presentation. I'm going to give you some boxes with messages during the presentation, okay? Those are key takeaways, so things that we should try to remember. We will have these things, we will collect them during the presentation, and then at the end, I'm going to pick them up one by one, and we're going to summarize everything very nicely by taking the different bits that we are having during the presentation. So that's the first takeaway. Knowledge graphs everywhere can be used for anything, very flexible. Then, how can we apply AI to knowledge graphs? I'll be super brief because you probably can imagine this part. We can predict new links. So for example, if I know that Barack Obama is the president of the US and Donald Trump is also the president of the US, I don't know, maybe they are related somehow, I can try to do this thing of predicting what lines are missing that I don't know are in the graph yet. Other thing that I can do is measuring similarities between things. So how similar is Barack Obama to Donald Trump? Maybe they're very similar because they are both related to the same things. I can try to measure that. You can apply reasoning processes. So if I have a mom and whatever, blah, 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 you can define some sort of reasoning rules. That's very classic AI. Like, this was done like many years ago already. And honestly, there's many more. But it all comes down to those ideas in general. So that's what we can do with AI on knowledge graphs. Key takeaway here, you can put intelligence into knowledge graphs with AI, right? Good. Now, let's have a word on what's this thing that's called a knowledge graph embedding algorithm. What's this? Well, the first thing that we should try to do is to define what's an embedding. What's an embedding? Do you know what's an embedding? Who knows what's an embedding? Good, good. So, great. Well, for those of you who don't really know, it's like just a concept, an idea, right? Like, it's a way of representing something for a computer. So, for example, a pizza is a concept, right? Like, if I tell you, think about pizza, something comes to your mind, right? You have a concept here. But if I tell you, okay, now think about a car, you think of something else. That's a different concept. How do we model this? Well, we just give numbers inside the computer to each of the things. And those numbers represent the idea. Okay, that's an embedding, good. So that's the only thing we need to remember. Like, an embedding is just a way to represent concepts. Now, don't try to read this. Like, I'm just showing you this to, well, give you the message that there's a lot of different algorithms that can work with knowledge graph embeddings. And what I mean by that is algorithms that try to extract the concepts in the knowledge graph. So you have your different things, and you try to extract what they mean, right? A lot of them. I won't dive into what all of them do because, like, well, we have like days of the presentation, but I'll just give you like a very simple idea. What's the general idea of all of this? Let's say we have a knowledge graph. So at my company, we use things like this, like knowledge graphs with genes, you know, for example, gene 1 causes lung cancer, also heart disease, gene 2 also causes lung cancer. That's a knowledge graph. Okay, good. So what do we do with this? We take the knowledge graph, we take an algorithm, okay, the training algorithm, we take the knowledge graph, it works, it does something, and magic, I get something. What do I get? I get embeddings. So I get the numbers that the computer thinks are those things. Good. So that's the general idea. I won't dive into this thing because like there's something else that's more interesting. So we could go deeper in that, but let's focus on a different part. Good. So real-world applications. What can we do with this? Probably you could have some things in your mind already, but some ideas. Predicting associations between the genes that we had here and other diseases that maybe we don't know yet, right? For example, you could say, oh, maybe gene 3 is probably related to cancer. Maybe I could start to do some research on that. And this is very interesting. I don't know if you know it, but I think 80% more or less of newly researched drugs. So like, you know, like when you research a drug, you have to start picking some genes to do experiments with. 80% of them fail. Like really, we really choose wrong hypothesis to start with. So if you have like an AI that can tell you, oh, probably this thing is what you should look into if you're trying to do research for this disease, maybe you can lower that 80% failure rate to 40%. Right? So that's one of the things that you could do. Another thing, drug repurposing. Do you know this drug that was like for diabetes? There was like a drug that was for diabetes, but then people started using it for weight loss. That's drug repurposing. So for example, you have a knowledge graph of what are people taking, what should be taking this for, and what are they actually taking this thing for. You can try to extract hypothesis of, oh, maybe this drug actually works for something else. Drug repurposing. What else? Facebook. Friends connected to other people. This person is probably your friend. Google. You know the PageRank algorithm. Yep. There's a lot of things, really, a lot of things. I'll let you think while I drink some water here. Sorry, I really needed to drink. And now, that sounds great, right? Like, up till this point, it's all wonderful. It's Disneyland, right? Great. But there's some problems, because there's limitations. Why? What are the limitations? What's the problem? Well, let's take the knowledge graph that we had before. So we had some genes, right? And we had some diseases, and we can try to train an AI to get like embeddings of the things, do inference of new things, great. But what happens if now I take the same thing? Look very closely here, okay? I'm gonna press the button now. What's gonna change here? The structure doesn't change, right? But the words change. Problem here is classical artificial intelligence is not able to pick up the differences in the text. So I would get exactly the same embeddings, exactly the same numbers, the same results, with the thing I had before, and this thing, which is totally different, right? It has the same structure, so it gives me the same results. But it's different. The semantics, the information is totally different. And what happens if I change? So you see the links are likes, right? But what happens if I change the thing and now I say it's hate? Oh, it's different. It changes again. So isn't it like a bit weird, right? It shouldn't be like that. There's something wrong. That's the limitation. So machine learning is great, but, well, not perfect, right? There's some things that we could try to improve, especially when it comes to the real information that is inside the knowledge graph. And that's what you can try to do with LLMs. And that's the interesting part. And this is the interesting bit of the presentation. So right now we are at the point, so let me explain to you like how this research field has advanced. First, we had classical ML, right? And it was advancing for some years. Great. Now we're here. We have this problem. This thing that like graphs are not able to pick up the semantic information in the nodes. What can we do? We can try to use language models to step forward, like a lot, right? And that's what I'm gonna be talking about in the next 15 minutes, more or less, and I'll leave time for questions later on. I'm gonna give you some examples of things we can do, okay? I'm gonna give you, because like here, really, this is like an open research field. There's nothing that's 100% set. Everything is very experimental. So I'll just give you ideas of different things we could try. There's more, really, like a lot of papers on this area, but I just picked some examples that I thought could be interesting to talk about and that you could have like in the back of your head. So one of the things that we can do is to use language models to streamline the process of creating knowledge graphs. For example, so I told you we work with genes, diseases, blah, blah, and those are huge knowledge graphs. Like the human body has like more than 20,000 genes that encode proteins, that do a lot of things. Up to this point, like that was done by humans. So humans had to literally write on their keyboards, oh, this gene does this thing, blah, blah. That's a lot of money, a lot of time, a lot of... It's so hard to do knowledge graphs, right? So what if we use language models to create them automatically? That's the thing we're gonna talk about now. So language models, they're great tools because they know a lot, you know, like they've read a lot of articles, a lot of websites, they know a lot. So we can use that background knowledge to train, or not to train, to extract the information that they know and create a knowledge graph in a nicer format, you know? So good, let's see how we can do this. One of the ideas is this thing that's called Comet. What's Comet? Well, the idea is very simple. You know, when we have a language model, we can simply like fine-tune it, right? So let's say that we fine-tune a model for this task. I give you a subject, I give you a predicate, and you give me the object. So for example, I give you Paris, I ask you, this is the capital of what? And you tell me, France. And I do this a lot of times. So the idea here is that the model, when I fine-tune it, it should be able to learn that if I ask you, for example, what is the capital? Sorry, Berlin is the capital of, I'm going to get Germany. That's the idea. Super simple. Good. It doesn't work fantastically well. There's other approaches that could be better, but this is one of the first things that was tried. And, well, it gave some results, sometimes. There's another thing that's more interesting, I think, which is called SKD, or symbolic knowledge distillation. What's the idea here? It's going to change. It looks the same, but it's different. So, you know, with ChatGPT, you can do this thing like you can give a prompt, right? So now I'm going to give you some examples, and you have to complete the example. So Paris, blah, blah, Madrid, blah, blah, Santiago. And then I give you the thing that you have to complete. So this is few-shot prompting, right? Great. The thing is, I don't fine-tune it. Like, I just prompt the model, no fine-tuning, no training. And what I do is, I do this process for a lot of things. A lot of things. So I get 6 million triples, like this. When I say triple, I mean the relation, right? 3 things, sorry. So I get all of the things. 6 million, that's a lot of things. Now the problem is, you know, ChatGPT tends to hallucinate like a lot, right? So how do I really know if those 6 million things are really true? What would you do? Like, how can you know if that's like real knowledge? Okay, I'm gonna tell you, okay? The idea that, well, the people that wrote this paper had was, I'm gonna use a thing that's called Amazon Mechanical Turk. Do you know what it is? Yeah? It's like basically exploitation. Like, I mean, so basically it's like, it's a website where you can hire people like for 20 cents per hour, and they have to complete tasks. So, yeah, I'm not gonna get into the ethics here. That's another thing. But basically, like, what they did was, okay, I'm gonna give like all of this knowledge to people, and they are going to judge if this is true or not. So I'm going to give the examples to people, they're going to click a button, and they're going to tell me yes, no, maybe. And they do this for 10,000. Not 6 million, just 10,000 of the things. So I'm not filtering everything, right? I'm just filtering like a small part. But then what they do is, okay, I'm going to take those 10,000 things, and I'm going to train a thing that's called the knowledge critic. This thing that's the knowledge critic, it's just a system that is able to classify the rest. So I trained the knowledge critic, and now I apply it over the 6 million things. And I get some predictions. And the knowledge critic tells me, oh, well, I think that out of those 6 million things, you should actually discard a big chunk of that, and you should only have 5 million, because it thinks that the other million is just not true. So that's what they do. Does it work? Well, quite a lot. I think, yeah, I have the results here. So I just wanted to give you this number. 87.5% of the things were good. So that's not perfect, right? It's not perfect, but it's acceptable. Especially to get like a thing that's 5 million triples. 5 million triples, that's a lot. A lot of knowledge. And you can get that sort of for free, you know, like you just run your model, knowledge critic, blah, 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 and you have a huge knowledge graph in days or maybe hours, you know? So like, it's an interesting tool that you can have like in your toolbox. Now, last example of this thing, because I think this is very interesting as well. There's another system that's called BERTnet. And it takes a different approach. Okay? What do you do with BirdNet? This is more for the cases where you are interested in something very specific. So for example, I want to get information about potential risks. So I'm going to give the system a prompt. I'm going to give the system the potential risk of something is this thing. And then I'm going to give examples. So the potential risk of eating candy is tooth decay. And more examples. So I give this thing to the system, and then the system automatically creates variations of that prompt. So it's going to rephrase it, because like sometimes when you ask ChatGPT in different ways, you get different answers. Just by asking like the same thing but in different forms. So what this thing does is like it creates like a set of forms of questions that I then can rank. So like I run them, I see that this question tends to work better. I run this thing through the model, my set of questions, and then I get some results. Up here, you see like potential risk, the table here. So for example, it's going to be able to tell me, oh, the potential risk of smoking is cancer, things like that. So this is more a specific application for building knowledge graphs of specific fields of interest. But it's a very flexible system, like it only needs like some input and then you get everything. So very interesting. Now, I'm going to give you another example about how we can use this to answer questions. How can we answer questions? There's something that's called Oreo LM. And I love the name because it's literally that. It's an Oreo. Like when you have an Oreo, it's like layers of things, right? You have like the cream inside, etc. So this is an Oreo. What this does is it takes a language model, it takes a knowledge graph, and they interact back and forth. And they get your answer. Example here. I'm asking, what cheese is used to make the cannoli? And then, if you wanted to get an answer traditionally, what you would have to do is you would have to maybe have like a system that recognizes the entities in the question, and then you would have to go to your knowledge graph and search for what's like a query that would get me to ricotta cheese, but maybe in your knowledge graph, there's no direct path, there's not like an obvious thing that would actually get you to the answer. So that thing doesn't always work. The change here is that I think I have some slides, like if you want to get like more technical, but the idea is just that you have a language model that asks the knowledge graph. And then it interacts again. So it sends a result, the language model asks again, and that goes on for some time steps, and then I get my answer here. So I get the ricotta cheese. Advantages here. This doesn't have to necessarily go through the obvious paths of reasoning. It's much more flexible. It can use this sort of, I don't know if I should call it intelligence, but abilities that language models have to go through paths that are not obvious necessarily, right? So that's what Oreo LM is doing. Very interesting system. Key takeaway here. If we combine language models and knowledge graphs, that's a world of possibilities. I've given you just some small examples, right? Things that come from research papers. But this thing is like always evolving all the time. So like new things are coming out. It's like everything in AI right now. So there's a world of possibilities here, super exciting. So the question is, what's next? What comes after this? Well, I'll give you some questions that I personally have. First of all is, most of those things are using either those types of graphs or those types of graphs. But can we apply to those types of graphs? Because those are probably the most interesting ones. Research hasn't actually focused very much on those. So is this applicable directly? Does it work? How well does it work? That's an open question. Then there's a problem with new nodes. I won't actually explain the thing, but basically the idea is, how do I give numbers to things that I've never seen before? How do I give embeddings to things I don't know yet? It's an open question as well. So adapting to new things, very hard. Can we use architectures like this thing we just saw for other tasks? Like, for example, predicting links. Maybe. How can we adapt it, etc.? How much do language models hallucinate? That's a whole question, right? Like, not necessarily about knowledge graphs specifically, but if they hallucinate like a lot, do we actually want to use them? It's all open questions, so I don't have the answers. But in general, this is what I would take out. There's loads of potentials here, and we need to keep building this thing. So that's the sort of end of the presentation, but let's recap. What have we seen here? This is where, you remember I told you, we're going to have some takeaways, and then we're going to get them at the end. Now it's where we do our fishing, and we take the takeaways from before. So first we saw that knowledge graphs are everywhere, right? They can be used for anything. Great. We also saw that AI can sort of put intelligence into knowledge graphs. But the problem is that classic AI is limited. There's some things that it doesn't do very well. So what can we do? Well, we can mix them with language models. And that's a world of possibilities. And that's something that's open to everybody, to the researching and to just explore the field. There's many exciting areas here. And that's what I would take out of this. But, well, in general, a lot of room for improvement at the same time, right? And, well, speaking about improvement, there's something I would love to ask you to do, which is, I need your feedback to help me improve. So if you, if you can help me, just giving me 20 seconds of feedback, that would be amazing, really amazing. There's a mini surprise after you submit, which is that if you submit the form, you get the bibliography. So it's like a paywall. You know, like when you go to the New York Times and it asks, first you have to pay to like see the contents. That's the same thing. If you submit the form, you have like the bibliography. You can read like more about the thing. And we have 6 minutes for questions, right? So if anyone has questions, feel free to ask.
Amazing.